Hi everyone. In this video, I'm going to demo an agentic framework called QuaIA, which stands for Quality Assurance with Intelligent Agents, dedicated to the intelligent automation of testing lifecycle, including requirements analysis, test case development, execution, and closure. The orchestrator is the central hub and part of the system. The framework itself includes 8 specialized agents featuring both UI and API, automated test execution, automated incident reporting with duplicate detection, and RAG-based Jira issue storage. Some additional features of the framework are the prompt injection protection, the monitoring dashboard, and the Google Cloud deployment. I'm not going to make a deep dive into the architecture and flow diagrams of this video, because everyone who is interested in a deep dive can find the documentation on the GitHub welcome page of the project. The links are provided in the description to this video. So this is the overview of the architecture diagram itself. You can see the orchestrator, all agents, as well as external systems on this diagram. Jira is further used as a ticketing system and Zephyr as the test management system, and the workflow diagram shows the core 4 workflows of the framework, which will be presented in this video. And now let's take a look at our 8 agents on the dashboard. So requirements review agent checks Jira stories for clarity and testability and provides the corresponding review feedback. Test case generation agent creates test cases based on acceptance criteria inside user stories and based on attached requirements. Test case classification agent is responsible for categorizing the test by type, for example, UI, API, etc., and if the test case is eligible for the automated test execution or not. Test case review agent checks the generated test cases for quality, consistency, and coverage. Now we move to the test execution agents. You can see we have the API test execution agent, which is responsible for executing the API tests, and we can also see the UI test execution agent. You can also see 2 maintenance agents. First one is the incident creation agent. It's responsible for automatically filing bug reports, and it uses quadrant vector database to perform semantic search in order to prevent creating duplicate report incidents. The second one is the Jira RAG agent, RAG update agent. This one keeps the vector database synchronized with the current state of Jira issues. Additionally, we can also see the view of the recent tasks which have been executed. Here we already see that the synchronization of Jira issues between Jira and our framework's vector database is complete. We also see the last registered errors, as well as the logs of the orchestrator itself. Now let's see an end-to-end workflow. I'll be using Jira instance with 2 user stories, one for UI and one for API. Both user stories are currently set in to-do status, and also none of those user stories has currently any comments added to it. Instead of the testing team to manually reviewing these for clarity and testability of requirements, we let the requirements review agent handle it. By switching to the status in review, the workflow triggers automatically. We will do this for both user stories at the same time. Now let's take a look into the dashboard. As you can see, we already have the Jira requirements review agent executing the task for the first user story. Let's wait until it's complete. And now we see that the agent has completed the task for the first user story, and soon we'll start the task for the second one. There it is. Because we have only one instance of each agent running in this framework, each task will be executed sequentially. Now we can move the first user story and take a look into the comments. As you can see, the agent has added review comments to the Jira user story with valuable enhancement suggestions based on both the user story content and its attachments. The feedback has, for example, suggestions regarding the ID inside the payload, which is used for creating the virtual entity of a pet. Because the payload itself is located inside the attachment, this comment proves that the agent analyzes attachments as well. We can now move to the second user story, where we also see a review feedback. So once each user story is finalized by its author, it's basically ready for the implementation by the dev team. It also means that the testing team can start with the test case design, and in order to spare its precious time, we delegate this task to the framework. Again, moving the status to ready for development will basically trigger the test case generation. Let's do this for both user stories. Now let's take a look at the dashboard, what's happening there. So we can see that the test case generation agent has been triggered. It's already processing the first user story. So we can see that the first user story has already been processed. And now we can see the test case classification agent jumping in to do the classification of the first user story. At the same time, we can see that the test case review agent has been activated to make a review of created test cases. And at the same time, we see that the test case generation agent is already processing the second user story. Now let's take a look at the Zephyr dashboard. As we can see, there is already the first test case there. But the first user story, the API one, it's also been reviewed because its status is review complete. And if we take a look into the test case itself, we will see that the test case has the labels telling us that the agent decided that this test case can be automatically executed and it's an API test, which is absolutely correct. And we also have review comments on how to enhance this test case to have a better coverage, consistency, and more adequate test data. So let's take a look at the dashboard. All agents are green now, which means all the tasks have been executed. We can see also all the completed tasks in the list, which test case has been generated, review, and so on. Let's move again to the dashboard of Zephyr. We have the second test case already there. That's for the UI user story. We have review comments there as well as labels. Each test case has test steps, objective, and preconditions, as well as links to the corresponding user story. We can also see that the test case, which has been generated for API user story, has already taken into account the attachments in the user story and retrieved the data from them and also added it as test data directly into the test data field. Test step actions and expected results are, of course, also there. Also, we can take a look into the test steps of the second test case for the UI story. We see all those fields as well. We can see the test data where it's relevant. Of course, these test cases still need to be reviewed by someone from the testing team and, if needed, adapted and have the status set to approved. Thus, the human remains in the loop. But the heavy lifting like drafting, test data generation, test case review, linking to the user story, and labeling have already been done by the framework. And now we move to the test execution workflow. Once the CI/CD pipeline is triggered, the orchestrator fetches all test cases that are eligible for automated execution. It then groups them by their type and distributes each type, in our case UI and API tests, to the corresponding agent swarm. For the demo purposes, I've prepared 4 test cases, 2 UI test cases, and 2 API. Each test type has 1 test case, which is expected to succeed, and 1 which is intentionally expected to fail, in order to show the incident reporting agent in action. All tests are executed in parallel, as long as the amount of agents allows it. We'll use a simulation of a CI/CD trigger in order to start the test execution. Let's take a look into the dashboard. And we already see, as mentioned, that API and UI test execution agents have been triggered. Because the current setup has a single UI test execution agent and single API one, we'll observe both agents simultaneously processing 1 test case at a time. We can't see the process of API test execution directly, except the logs, but we can observe how UI test execution agent does its job. So let's switch to it. You can see the Linux operating system with the desktop where Google Chrome browser is installed. What's remarkable here is that this UI agent operates purely based on visual information and uses only keyboard and mouse to execute all actions, which is an innovative approach. Most of the contemporary AI agents which execute UI tests work directly with DOM for web or mobile applications, or they work with accessibility libraries like Windows UI automation for desktop apps. Such an approach leads to driving the application actions not exactly in the same way as the actual user does. That's why the presented here UI testing agent tries to simulate the actual user as much as possible. No code, no selectors, no DOM parsing, etc. You might have noticed the slowness of the execution, which is purely due to the latency of LLMs used behind the scenes. But this latency keeps getting better every year. And based on the huge investments into the hardware acceleration, like for example, recent acquisition of inference platform Grok by NVIDIA, it's only the matter of a couple of years until the latency of such models drops drastically. We can now see that the API test execution is complete. We can also see that the first test case has been executed. Now let's wait for the remaining test case executions to be complete as well. All test cases have been executed. We can see them in our tasks list. We should also see the incident creation agent triggering in. And here it is. This agent is supposed to create 2 incident reports because we have 2 failed test cases. However, if we take a look into the backlog, we will see a bug ticket there from the last execution, and it relates to the API test case. And because, as I mentioned at the beginning, we have synchronized all our Jira issues into the vector database, only one incident report needs to be created, because the other one is a duplicate of this bug, and the agent will detect this duplicate using semantic search and analyzing its contents. And if we wait a little, then we'll see exactly one incident report created in Jira. As expected, it relates only to the UI test execution. Let's see the execution results now. We have 4 test cases executed. Now let's take a look into the first one, which is the one which was supposed to be successfully executed. It's quite important to understand that every execution agent captures the actual state of the application after each test step execution, providing the most relevant information about it. It means we can have info about executed requests, status code, results of validating API schema, etc. We also get the corresponding justification of why the verifications were successful. As we can see, every test step was successfully executed as expected. Let's move on to the second API test case, the one which was designed to fail. Because no new incident reports were created for this test case, we see the info about the identified duplicate tickets in the comment, as well as the link between this test case and the identified duplicates. We also see that the first test step failed because we expected different status code, and we have a justification of why it failed. Let's move to UI test case executions. As expected, this first test execution is successful. What is very important to note is that the test data we use in such test cases doesn't have to be in specific format and doesn't have to be exactly the same as the one that needs to be provided for the action. For example, on this calendar, we want to click the feed forward button until we have the target month inside as the first one in the header of this calendar. What we do is we provide the date in general, not specific value of the header, and instruct the agent what to do, and the agent figures out on its own what the exact value of the header should be. In this case, it's February 2026. And we can see that the agent justifies the success of the verification saying what is visible on this calendar. The similar approach is taken here because, for example, the test step click on the day number on the calendar We don't provide the exact icon number to click on, just again the general date. And this data, and in general all test data, can be saved into a file or specified in a custom field of the test case itself, and then simply loaded into the test execution context and referenced in each test step, thus avoiding duplication and facilitating data-driven testing. And the agent itself will figure out what exactly it needs from that data. That's something that is currently impossible in the classical test automation. This approach also allows to spare a lot of time on adapting test data for each specific test step. Anyway, we can see that every test step is green, and we can see that every actual result is there. If we move back to the execution of the last test case, the one designed to fail, we will see that it actually failed. We can see in the traceability section that there is already a new bug created and linked to this failure, and a comment describing why it failed, as well as the info about newly created incident report. If we take a look into the failure description itself, we see the justification of the failed verification. Because our dropdown had values which didn't correspond to the ones in the expected results. Visual AI verification is actually one of the greatest advantages of using AI agents. It can capture multiple issues in one round of the verification. For example, check multiple messages or the whole data form if it was correctly filled out, the relative positioning of elements, different UI effects, etc. Something that is definitely impossible using classical test automation approaches. Let's take a look into the bug ticket itself. The bug ticket has the name of the component in its summary, description, environment details, as well as steps to reproduce and expected and actual results. Important is that we also have the logs and screenshots attached to it. And the last important part is automatically generated HTML report. We can see 4 executed test cases in it. As expected, for each test case, we have all our steps, all actual results, and we can see also log files attached. Because this is an API test, we don't see any screenshots, only logs. If we go, for example, into the failed UI test case, we can see not just the executed steps, but we can also see the screenshot. Those HTML reports are quite important as a part of the execution artifacts and could be easily used for any purposes. For example, during audits, for generating reports for test management, calculating KPIs, etc. And this is it when it comes to the test execution. We have finally reached the end of the demo. The key philosophy remains the same. All that can be intelligently automated should be under supervision and decision-making of a human being, which is exactly what we need for the current state of AI development. The agents assist, but humans remain in control of the critical decision points. The framework presented in this video is open source and available on GitHub. The links to both repositories are in the description below. Both projects include comprehensive documentation and deployment guides. Thank you a lot for watching this video. If you have any questions or suggestions or would like to contribute to the project, feel free to reach out. Bye bye.